It is a pleasure to be here. My involvement with IDCC has been limited to hosting a workshop with some other familiar faces here last year. So it's really a joy to be here for the full event and also to tell you a little bit more about what we do at Digital Science. So I know that I am the only thing keeping you from lunch. So we'll go through, there's lots of pictures, and you can feel free to ask questions afterwards because I don't want to keep you from getting any sort of nourishment. But my name's Kaitlin Thaney. I'm the Manager of External Partnerships at Digital Science, which I'll tell you a bit more about. And this talk will feature some of the tools that we're working on and also give you a little bit of the explanation as to why we think these are important and really pertinent to the issues that are being discussed here. So to give you a little bit of background, I don't know how many of you have heard of Digital Science before. We came into existence publicly about 2 years ago, last December. We're owned by Macmillan Publishers, sister companies with Nature, the scientific journal, which I'm sure pretty much everyone here in the room has at least heard of before. And the reason that we came into existence was to really address some of the issues that we've been facing in a number of different circles, the things that are by no means new to the crowd here at IDCC, but in how we can start to embrace and use technology more to our advantage, whether that's working with data, whether that's updating our broader information practices, information management practices, and just the way that we do research. Somewhat tied to publication, which is no doubt an important part of the process, but also looking at how the research is happening and the knowledge discovery much further upstream to see what we can possibly do. So a little bit of background, Digital Science. We are based in London. Don't be fooled by the accent. We just opened an office in Boston, and we also have staff in New York and Tokyo. In the last 2 years, we've grown from 5 to about 45, slightly more than that is our core staff. And with our portfolio companies, which I'll explain a little bit here in a short while, we're now, I believe, at about over 120, which is some really dramatic growth for 2 years of existence. Digital Science, we serve as a bit of a hybrid. We're the first technology division that Macmillan has ever had. Macmillan is a publishing company. They're known for their content businesses from Pan Macmillan and Palgrave to Nature. We are the first technology company and software division that they've ever had. And it's a very deliberate choice on their part. We work to make research more efficient, hence the title of the talk, in a number of different ways. We've got a multi-pronged approach, and so we've got 3 different research divisions, which you'll see throughout this talk, to help us break up our thinking and how we craft tools for various parts of the research community and research cycle. So inevitably, one of those is the researcher themselves, but also looking at how we can create tools to help match resources with the decision makers, the funders, and also the research administrators, people that are measuring impact and helping with incentive issues, and then also how we can start to better use our technical backbone, or as I like to frame it, tools for machines, to do better knowledge discovery to really help on that end as well. We craft tools internally, which you'll hear more about in the next few months with our first few projects that are coming out into existence. But the tools that you'll hear of today are projects and startups around the world that we incubate at Digital Science. And by incubate, these are full-on investments that we're the majority stakeholder in, and that we work very closely with to help build out and help integrate with other tools and services and then build their presence as well. So without further ado, here's a snapshot of some of the tools that you can actually go and use right now that Digital Science supports. And some of these may seem familiar to you, some others a little bit less. And I'll go through, I believe, almost all of these in this talk. So as I said before, we've got 3 major research divisions broken down from our knowledge discovery unit, or creating tools that help with machines, to our research division, and then also we've got a science metrics division, which looks at creating tools for those influencers in the research cycle. Starting with machines, one of the baseline assumptions that is, again, by no means new, though there are some people here in the audience, one who's sitting in the front row, who is much better at this than many others when it comes to dealing with forms of information. But considering how the community that we're serving is vast, looking at how discovery is really suboptimal in most of the research practices. So an example in chemistry, still, I know it's not perfect, but still the starting point just for a sanity check to see even what news articles or what things have been published about a certain thing that you want to start your research on. This example here, you're not going to be quizzed on it. It's a tricyclic antidepressant. It's sort of in that family, similar to diazepam. But you can see just the information overload issue here with 1.5 million results. It's not necessarily filtered in any meaningful way, and so it's not incredibly helpful. So let's go one step further. We'll look for diazepam in the US patent database. It still shocks me that this is what the US patent database looks like. Perhaps that's just me, but it just reminds me of GeoCities with the scrolling marquee that will come any moment across the screen. But still looking at 1,100 results, and anybody that's done any work with patents, first off, I'm sorry. But second, you'll know that these are usually intentionally confusing documents where the information is quite hidden to be used almost as a scare tactic. So it presents some really interesting OCR issues and also how to, and text mining issues where it's very difficult for machines still to this day, unless it's a very, very pricey solution, to be able to pull from that whether or not a compound, and say you're doing this for early stage drug discovery, as some of my colleagues are doing, being able to discern from that whether or not a compound is covered by the patent or is just listed as background reference is something that does take a little bit of additional finesse. Name disambiguation is another massive issue. This is paracetamol on the right-hand side. I stopped counting how many other synonyms there were, and those that work in the bioontology sphere know this all too well, when I got to about 100, and the list just continues to go on. Now, if you start to think about the information architecture on the web and how and the knowledge resources that could be pinpointed and hanging off of any one of these names, very seldomly, and there are groups that are working diligently on it, are those brought together so that you can actually search all of that information instead of just having it in silos. So the first product I'll tell you about is one called it's from SureChem. They relaunched their product line in late last year. Their first tool is open to researchers. It was a very deliberate choice. This was a tool that came out of the almost the biotech pharmaceutical side of things, back when knowledge management systems were really used in in a very closed sort of fashion. The reason that they made this open is really to help bridge the relationship not only between pharma and biotech, who still use SureChem, and those are the patent offices, but also with researchers, because this sort of drug discovery and this sort of research is really no longer the province of just big pharma. So it's a free tool that people can use. And I'm not going to go into this in too much detail, getting into chemistry, because there's quite a lot to cover. But what they allow for you to do is being able to sift through these patent documents, not just by looking at sophisticated means of stitching together all of those synonyms that you saw before, but also trying to hack it so that it is tailored to the way that researchers think. So in this sense, being able to just draw a chemical structure is actually a lot more intuitive than going through and remembering all of those different synonyms, and seeing how it can then be stitched to content in various sources and other additional information, which I know is probably too small to see at the bottom, but the slides will be made available afterwards. They also are working to link to other open chemistry resources. One of the comments made earlier today is about publications becoming the linking hubs. And so this technology not only drives the annotation for Nature Chemistry, but is now also linked to tools and resources from the Royal Society of Chemistry and ChemSpider to help create a more comprehensive source. By no means are done with this just yet, but at least is a nice starting point to see how we can start to make this a bit more of a useful thing for researchers. Which brings me on to our probably most active division, our research tools division. And looking at the themes from today about infrastructure and innovation applications, our definition of data is definitely changing. I know that in most cases here, I'm probably preaching to the converted, but bear with me, or at least is long overdue. So the people that we work with as mostly bench scientists, though we do have a number of tools that can be used outside of the life sciences. Most of us come from a life sciences background, so makes sense that this is our first area here. But this is the information workplace that we're dealing with here. Mostly managed by Post-it notes and stickers and stacks of invoices that go into non-existence and poorly labeled test tubes with researchers coming in and out of the lab. Some are better than others. Still dealing with a mix of digital and analog inputs here, which are gradually moving, but we're still quite a ways from just yet. Also, information sources like which freezer is my material in, how much of it might be left, how active might that be. Expiration dates. There are some expensive jugs of milk in most biological labs. If you're talking about an antibody or a number of materials that took you on the short end, maybe 2 months, on the relative end, probably about 6 to 8. Some of these tools, some of these materials are in negotiation for up to a year. If you're tech transfer office, it's particularly helpful. But then not having any idea as to how much of it might be left or the expiration date, and being able to have to start from the beginning, is a very real issue in most research labs, just trying to make sure that we know where all this information is being held. Then you have all the other additional bits of information, such as the protocol, the parameters for your titrations, your calibration, the miscellaneous literature, that often moves with when researchers move through the labs, which if you've got postdocs or graduate students there could be quite frequently, and you can see how this can be a bit more of an information loss than we can have, leading to quite a bit of waste. Also, even the ordering and processing information. I used to work over at MIT, and I know that the lab manager that was working across the hall, she didn't have a degree in the discipline that she was helping with in terms of managing the lab, but was doing the logistical information, and that information wasn't being communicated to the researchers and seldom to the PI, or at least only in a certain intermittent basis. And so trying to find a means of bringing that all together, and of course the research data from the researchers themselves that they collect while they're studying. This is actually from Mark Hannell from Fixture, who's somewhere in the audience, a snapshot of the data that he collected while he was getting his PhD in stem cell biology. So we can use data to better optimize and better enable researchers for changes in behavior, changes in productivity, better science, reproducibility, all of these big and better things. So that, while serendipity in the lab is great, and accidental discovery is something that we don't want to squelch, that we can have a bit more of a process there and use this information to build on what we've already known here. And this is one of my favorite little cartoons because it just seems like he's pulling random bottles off the shelf, which is incredibly dangerous. So one of the first tools, this is from a company that we work with out of Tel Aviv, started by a researcher who got really frustrated with the overly clunky, incredibly expensive lab information management systems that oftentimes just get pushed down on labs to try to make sense of this information. Seldom are intuitive enough or affordable enough for researchers to really make sense of them. There's a huge burden and barrier to entry. And so LabGuru serves as that lightweight system that allows PIs not only a portal to be able to check back in on the work that's going on in their lab when they're out getting more funding or giving talks at events like this, but also for researchers to have broader context as to what they're doing. So if I have to do monitor a couple different Petri dishes, I can understand what that task is in the broader sense, instead of just being task by task, and also ways of communicating with the researchers in your lab as well. They also were trying to figure out a way of creating a little bit less of a burden in terms of copying that information into that system. And so there's an iPad app that you can get as well, and I'm sorry this is a poor snapshot, but you can at least see the mechanics of it. And so in a very basic way, you can load it with your experiments, and it syncs automatically all of your results back to your main LabGuru account and shares that with the people in your lab that you can designate. And also it walks you through your protocols. And they also are now working with other groups from Nature Protocols to also Sigma Life Sciences and Luminex to start to preload some protocols as well, some of the most commonly used ones, so you have a starting point. And it automatically will put in a timer here, and it's fully customizable so that you can just go through and it keeps track of where you are in that experiment. If I could have this for when I'm just cooking at my house, it'd be really helpful. But I've heard that it is quite an assistance in what you're doing in your research. The next tool here moves into the data space, and this is probably if I had to venture a guess, what most people in this room would probably be most aware of out of our portfolio. And Mark, could you raise your hand, sitting in the audience? So there's Mark Hannell on that side. He's the founder of Fixture. So please do bend his ear. Fixture is an open data tool that allows you to share your information. All of the defaults are set to open. If you want to keep anything private, I believe you get up to 1 terabyte of private space. You can use this as a staging server. But it allows you to see and add all of these other sort of vanity metrics as well, playing to the researcher's ego. I've got things in Fixture, and I will say that it is quite fun to see how many people have viewed and downloaded your information. But the most important bit here is that it takes not only your figures and your data sets, it takes other forms of media, your posters, your papers. You can create file sets and organize your information. It provides a DOI for everything that you upload. It's stupidly simple, it's incredibly fast, and the barrier to entry is almost non-existent, which is something that we've needed for quite some time, and especially when it comes to some of the things that we've learned from the institutional repository system, not to hate on the institutional repository, people that are in the audience, but trying to find means of bringing this information together at a very low barrier to entry that meets metadata standards and also has lasting persistence and discoverability baked into it. So I encourage you all to give Fixture a look as well. Another thing here, and it looks like there's something over the TripAdvisor logo on the top. That is supposed to be the TripAdvisor logo. Using data in ways that allow us to make better educated decisions, and this will also come through in our metrics division. If you were able to look at, the ratings for your antibodies or the biological materials there, in antibodies it's a particularly nasty problem. The efficacy in antibodies alone is quite horrible. If you can buy the same antibody from about 5 different providers and maybe 2 out of 5 will work and you don't really know until you're already halfway through your experiment. So being able to rely on things that as a digital consumer completely outside of the scientific discipline, it's just become a natural part of our life. I mean, if you were to go through and buy something online, most of us would just inherently go and type it into Google, which brings up the Amazon reference there, which we can then go see, is this a product that I want? Or some way to make an educated decision in that side there. And so one of the companies we work with in Toronto is doing just this. They got really sick of that issue of not knowing, kind of in that buyer beware sense, what they were actually going and purchasing. This came out of some folks that were working at the Structural Genomics Consortium in Toronto under Al Edwards, if you know Al Edwards. And what it is, it's the first time that there's been an open access catalog bringing together listings from most of the major providers in biological materials that people can then go and sift. And the providers, make this information available because it's, of course, better exposure for their materials. But then they also invite researchers with some small review so that people aren't going and flaming against a big provider. So it's constructive reviews there. They can put data and other reviews there so they can say what their experience with this certain provider is, or if this necessarily worked in their experiment, or if it ruined their solution, etc. They started off with antibodies and are now moving into other reagents, services, digital tools. They have an epigenetics portal, a stem cell portal, etc. So that people can have more information when they go to buy from their provider. There's also things that you don't really think about when it comes to using data to better enhance our research experience. So we've got a company that we're working with, and they just put out, actually recently in the last 2 weeks, the top-line results from a lab safety survey that they ran with the University of California's Center for Lab Safety and also Nature Publishing Group. So it's a company based in the States called BioRaft, and they ran this survey to try to see what some of the issues were in lab safety, following on some of the major news in 2008, where a 23-year-old student didn't have any training using a certain substance and unfortunately perished. And trying to change that culture now that there's a bit more attention in that. So there are other ways of looking at that tracking information so that you can start to change the practices in your lab. And that company is called BioRaft. And I know I'm running a little bit short on time. So the last bit here touches on some of the tools that we look at to really look at the social problems, the incentives, the rewards issues, and how we can use technology to better that. And so when we talk about how to change behaviors, and the existing system's really imperfect. Kudos to Paul for beating me to putting Dilbert into a comic, but this is how I think of not only impact factors, but also how some of the higher education bodies award funding in the UK, just for example, about just making up certain numbers, and we can do a lot better. This is by no means new, and we now have the ability to add context. We don't need to necessarily just rely on the name of a journal to be able to, be able to glean from that what or how powerful that science may be. Altmetric is a company that is based in London, and what they do is they look at taking from the DOIs for various research articles. They look and scrape the entire web to see what other online conversations are going around about that article. So that it may have only 10 citations, but it may have been discussed 10,000 different times, and it may have had data on Fixture that's been downloaded the same amount. And so how can we start to use that to change the way that we not only engage in online discourse about our research in terms of public engagement, but also start to understand the impact that it might have in the broader community and even beyond. Thinking of administrators and funders as influencers and drivers of behavioral change, we also like to keep in mind sort of the institutional heads as well. And this is the last tool that I'll be speaking about today. This is a tool called symplectic. It was created by 4 theoretical physicists that came out of Imperial. And in the UK, and many people here are from the UK, but for those that aren't aware of the REF, the Research Excellence Framework, or what used to be known the Research Assessment Exercise, it's a massive data collection exercise where institutions need to provide information about what output's coming out of their university, which then dictates how they get funding and get ranked, et cetera, et cetera. And there are certain other benefits of this, of course, to other universities around the world, to be able to have a snapshot of what's going on at your university, which is incredibly difficult to map if you don't have the right tools for it. So this tool came out of Imperial as these 4 theoretical physicists listened to one person whinge about the fact she had to pick up the phone and call every single department, figure out who was currently on staff, what papers they'd recently, and she was doing this all by hand. And so, that's, of course, silly. So this is an older snapshot. They just released a new user interface, but I didn't have time to snag it. But what it does is it goes through and it bakes into your institutional system, and then goes through and scrapes your HR index, so it automatically updates and creates profiles and takes down and archives profiles for people that are working at university. And then, without having the onus be on the researcher, it goes through and looks at things like Web of Science and Scopus and the main journal archives. It pulls up, says, is this an article that's yours? Does a disambiguation? Check 1, check 2, and helps build that profile for you. And you can attune it to look at other sorts of things, such as your collaborations, your teaching activities, the data sets you've made available, the biological materials you've made available, etc. And so they're working with others to also try to change the practice at the university, maybe encourage a behavior change in terms of putting information into your preprint repository or into your regular repository at university, but also giving better understanding as to what researchers' influence are at their universities and using data in that side as well. The changing models of authority, this is just one of the closing points, is that we don't necessarily need to look towards one definitive source anymore. We've got a plethora of these things, and we're trying to help at least stitch some of these together, or at least better understand what we can glean from those and what insights can come, so that we can start to better understand where we sit in the research community. And the final point is that we really are battling tradition, not just technology, though digital science is about providing the tools and the broader understanding as to how these things can make a difference. And that's it.